to do a quick video about the different types of numbers, the different types of subsets of real numbers. These are all things that you've been exposed to before in earlier classes. I mostly just wanted to make a nice, easy, quick video so you guys can get accustomed to looking at the videos as your homework. All right. So the first one I wanted to talk about is the natural numbers. It's the ones that we count with. So 1, 2, 3, 4, 5, etc. And then usually there is I'll show you how that's written, and we'll see in the book, but it's like an N for natural. But one of the things is thicker. That's natural numbers. That is a standard way of writing the special subsets of the real numbers is with letters that look like that. You got the N for natural, and then one of the things, this guy is kind of thicker. It's real exaggerated. So it's all the numbers that you count with, 1, 2, 3, 4, 5, etc. 6, 7, 8, 9, 10, forever, never, never. Infinitely many of those. Whole numbers we use W for whole numbers. It's everything within the natural numbers, but then also zeros. It's the only difference. Right? Includes zeros. Whole numbers include zero, natural numbers do not. That's literally the only difference. Okay? The book is weird in that they use a different letter. I have never ever seen, this is the only book I've ever seen this in. Algebra 3 book uses a J for integers. And I have no idea where that comes from. Now Z seems awfully weird as well. Pretty sure, actually I tell you what, I have forgotten what the Z stands for. I think it is a German word. But don't quote me on that, I don't recall. Okay, integers, J in the book, or Z, you'll see in a lot of the books. So what are those? It's the natural numbers and their negative counterparts and zero. All right? So 0, 1, -1, 2, -2, 3, -3, so on, forever, never, never, in both directions. Those are the integers. There are numbers that don't have a fractional part. So if you were to include decimals with the integers, you wouldn't get any. If you have 2.0, you don't ever need decimals for integers. Rational numbers are ones that can be written as a fraction, where the numerator and denominator are both integers. All right, so it's kind of wacky. But the idea is that that actually includes all the integers themselves, because you can always write any of these as, I'll write this with the disappearing ink, the magic pen here, 5 over 1, 4 over 1, 3 over 1. So you can write all of those as something over 1. The definition of a rational number is that you can write it as a fraction where the top and bottom are both integers. So it's kind of the most abstract that we've looked at so far. And so, well, what about these guys? And so those frequently have decimal parts that aren't zero. So 2.5, 2/3. All right, so these are just a bunch of random examples that I threw up there. All right, and this guy, I'll do this with the disappearing ink again. That is 5 over 2. So that can be written as a fraction. This guy's 2/3. Oops, I didn't mean to do that. There you go. 2/3. This guy is -1 over 3. Right? So all of them, there are a whole infinitely many numbers that can be written as a fraction with the top and bottom being integers. So rational numbers, which is Q for quotient, by the way. Quotient is a division problem, so hence, rational numbers have to do with division. So that's why we use Q for quotient. Okay? But they're all the numbers, they're all the integers plus the fractiony ones in between. The next one, we're almost done, is irrational numbers. So all the ones that cannot be written as a fraction with top and bottom as whole numbers, or excuse me, integers. Okay? And you'll just have to take my word for it that that's the deal. Right? Some of these, actually, it's kind of hard to prove that square root of 2 is irrational. That pi is irrational. That the square root of 5, well, negative, is irrational. It's not easy to show necessarily. The symbol for irrational numbers is I. There you go. Last but not least, it's everything. Well, not really necessarily everything. The ones that we're used to is real numbers. This is everything from negative infinity to positive infinity. Okay? Everything between negative and positive infinity, like we discussed in class. So there you go. That's real numbers. So no big deal. There's no there's no assignment that's going to go with this. But I wanted to make sure that you are familiar with these terms and know how to get the videos.